Have you ever wondered why there are buildings that are not easily disrupted even with a massive earthquake?
Or how there are buildings that are easily swayed even with the minor quakes?
Well, all of those occurrences are associated with geology.
And if you don't know what geology means, well, geology is an earth science that studies the physical earth, the rocks that makes it up, and the processes that cause them to change over time. It is also describes the structure of Earth's surface and subsurface, as well as the processes that have shaped it. It also includes techniques for determining the relative and absolute ages of rocks discovered in a specific place, as well as describing the histology of the rocks.
So how does this relate to civil engineers? Well, engineering geology deals with the study of the structure of the earth in relation to the civil engineering or the execution of safe and cost-effective design for construction projects. Thus, as students aspiring to become civil engineers, it is vital to be well educated because all work performed by civil engineers involves earth and its features. Hi, I am Matthew Stenmiro.
And I am Eunice M. Lakno. We are first-year civil engineering students of Section B from Eastern Visayas State University, instructed by Mr. Vicente Duallo.
So without further ado, we, the students of Bsce 1B, are going to present our video lectures discussing about the basics of geology for civil engineers.
Good day everyone, I am Carl Vincent S. Balicante from Section CE1B, and I have here a short discussion about structural geology. Structural geology. It is the study of factors such as origin, occurrence, classification, type, and effects of various secondary structures like faults, joints, and rock cleavage. It is the result of the powerful tectonic forces that occur within the earth. Geologic structures forms because of deformation. These geological structures all begins with the scientific theory of plate tectonics, which is the description of large-scale motion of the plates of the earth. So during the movements of the plates, it includes forces, and there are three types of forces. First is the compressional force, where forces are moving toward each other. Tensional force is the second one, where forces are moving apart from each other. And lastly is the shear force, is where forces are perpendicular to each other. And we also have the types of plate boundaries: the convergent, divergent, and transform boundaries, where convergent means two or more lithospheric collide, and divergent is the two tectonic plates move away from each other, and transform boundaries, the plates slide across to each other. The forces create geological structural elements such as strike, dip, folds, joints, faults, and unconformities. Strike refers to the direction in which the structure is present, while dip means the slope or inclination. Folds is one of the most common geological structures found in rocks. Folds refer to the bended horizontal layer of a rock when it is subjected to compressive forces. Joints and faults are described as fractures found in rocks but with difference in the type of displacement. And unconformity refers to the break in sedimentation in between conformable beds. So that's all guys, and thank you and God bless.
Hi, I am Justin Arondina from Bsce 1B and EVSU Stan. In today's video, I am about to present to you Lecture 3, which tackles about geological maps in stratigraphic sections. So the objectives of this lecture is to give a brief meaning what geological maps are, these various types of geological maps, evaluate different methods of geological mapping involving its different equipment used, and also know at least what that stratigraphic section means. So geological map is a special purpose map made to show geological features. Rock units or geological strata are shown by color or symbols to indicate where they are exposed at the surface, which shows bedding planes, structural features such as faults, folds, foliations, and lineations. These dimensional geological maps are the basis of all geological work, even laboratory work, for it is pointless to make a detailed investigation of a specimen without geological maps. Just, of course, to know that there are types of geological maps. So these are reconnaissance maps, regional geological maps, detailed geological maps, and specialized maps. So without these maps, as mentioned before, it is pointless to investigate something beyond the surface of the earth. So also, there are methods of geological mapping: the traversing, green line mapping, drilling, underground mapping, and geology. So these methods are mainly or commonly used by experts, particularly geologists, on investigating something, rocks or beyond or beneath the surface of the earth. So these are the methods that are mainly used by some experts. So in that particular field, these are the field equipments that are used by those who are in charge, or experts, geologists. So these are the hammer and chisels, compass, binometers, GPS, scales, dates, map costs, field notebook, azimuths, global position system, and etc. So also there we talk about stratigraphic sections. It is a visual representation of a field outcrop. So it mainly talks about the composition or distribution of rocks beneath the surface of the earth, or beyond actually. So there are mainly two types of stratigraphic sections: the weathering profile, or this they look like, and the grain size. So mainly it talks about the rocks beyond or beneath the surface. So in this lecture, I've learned a lot, especially on knowing what geological maps are and its types, and also what methods experts or geologists are using it to investigate something beneath the surface of the earth. So it is very relevant to the subject we have in geology, really, because we know that geology talks about rocks, or what is happening beyond or beneath the surface of the earth. So it is very enlightening for me as a student taking a civil engineering course. So that would be all, and thank you. That's all for lecture 3, geological maps and stratigraphic sections. Thank you.
Good day, I am Mr. Renata, first year civil engineering student, section B. And today, I'm going to talk about the remote sensing and civil engineering. Let's talk about the uses of remote sensing. First is for site investigation. Remote sensing is used extensively in site investigation. for dams, bridges, and pipelines. It can also be used to locate new construction materials like sand and gravel for the new projects. Remote sensing is useful in selecting sites for bridges because remote sensing will help you determine where are the slopes, the terraces, and the valleys so you can find the best location for bridges or a project to construct. So, remote sensing is also used in terrain mapping and analysis assessment. But first, what is terrain analysis? Terrain analysis is the analysis and interpretation of topographic features through geographic information systems. Such features include slope, aspect, viewshed, elevation, contour lines, flow, upslope flow lines, and downslope flow lines. So, remote sensing is used in terrain mapping for terrain evaluation. Again, remote sensing is used in terrain mapping for terrain evaluation. The another use of remote sensing is for disaster assessment. Satellite remote sensing covers wide range areas, operates continually during all hours and in all types of weather, and is used to survey Earth's surface and atmosphere to study global environmental problems and monitor disasters. There are many uses of remote sensing, but these uses fall into category. First is for land use, where remote sensing, mapping of larger areas is possible in a short period of time. Forest area, agricultural area, residential, and industrial area can be measured regularly and monitored through the use of remote sensing. The second category of the use of remote sensing is for site investigation. Again, remote sensing is used extensively in site investigation for dams, bridges, pipelines, roads, or any construction projects. It can also be used to locate new construction materials like sand and gravel for your new projects. The third category of the use of remote sensing is for resource exploration. Geologist uses remote sensing to study the formation of sedimentary rocks and identify deposits of various minerals. Also, to detect the oil fields and identify the underground storage of water. Remote sensing is also used for identifying potential fishing zones, coral reef mapping, and to find the other wealth from the ocean. The first advantage of using remote sensing is that it offers georeferenced information and digital information. Remotely sensed data can easily be processed and analyzed fast using a computer, and the data can be utilized for various purposes. So the second advantage of using remote sensing is for easy acquisition of data over inaccessible areas. Remote sensing allows for easy collection of data over a variety of scales and resolutions. The third advantage of using remote sensing is that a single data can be used for different uses, because a single image captured through remote sensing can be analyzed and interpreted for use in various applications and purposes. There is no limitation on the extent of information that can be gathered from a single remotely sensed image. And now, let's talk about the resolution of remote sensing. So let's talk about the spatial resolution. Spatial resolution refers to the size of the smallest feature that can be detected by a satellite sensor or displayed in a satellite image. And now let's talk about the second type of resolution, which is the spectral resolution. When we say spectral resolution, it refers to the ability of a satellite sensor to measure specific wavelengths of the electromagnetic spectrum. The finer the spectral resolution, the narrower the wavelength range for a particular channel or band. The third type of resolution is the radiometric resolution. That refers to how much information is in a pixel. and is expressed in units of bits. A single bit of information represents a binary decision of yes or no, with a mathematical value of 1 or 0. The fourth type of resolution is the temporal resolution. It refers to the time between images. The capability for satellites to provide images of the same geographical area more frequently has increased dramatically since the dawn of the space age. So have you ever questioned what can be seen from a satellite images? So, we can see the rock types, the sedimentary rocks, the igneous rocks, and the metamorphic rocks. We can also see the geological structures, the alignment, the fault, the dike, the valleys. We can also see the black soil cover and the salt-affected land.
Good day everyone, my name is Janaise Dea Teofero, Bsce 1B from Eastern Visayas State University. Today we're going to talk about our topic in geology, which is the physical properties of minerals. So what is minerals? Minerals have unique physical features that can be utilized to determine the mineral's identity in most circumstances. You will establish a systematic approach to using the physical features of minerals as identification tools, and you will be able to identify the majority of common minerals, or at the very least, reduce possibilities to only a few. So most minerals may be distinguished and classed by their distinct physical qualities, which includes hardness, luster, color, streak, specific gravity, cleavage, fracture, and tenacity. Minerals' physical qualities are linked to their chemical makeup and pattern. Some features, such as the mineral's hardness, are more relevant for mineral identification. Color is easily visible and evident, although it is typically less accurate than the other physical attributes. All minerals have value. However, it varies. The more expensive a mineral, the more rare it is. The same is true for mineral utilization. When a mineral like copper, if utilized for a variety of purposes, it becomes valuable. Some minerals, such as diamonds and other gems, are mined for the beautiful properties. So why engineers required to learn physical properties of matter? Engineers digging oil and natural gas, of course, they will meet clay in the drilling fluids, used to cool, lubricate, and flush rock chips from the well, as well as in the rock they are drilling through. Different clays react differently to water and salts that may be dissolved in water, and if it collapses, it is a very bad and costly outcome of failing to pay attention to the qualities of the rock being drilled. Knowing the chemical and the physical properties of any material is more than just satisfying one's curiosity, because the things you see around you did not appear in the shape you see by random.
So, hi guys, I'm Michael Joseph Pablen. I'll study of Bachelor of Science Civil Engineering of Eastern Visayas University. So today we will discuss about crystallography and optical properties. So optical crystallography is the branch of science that focuses on the optical properties of crystal, also known as crystal optics. It describes the behavior of light in isotropic media, such as crystal, in which the light behaves differently depending on which direction the light is traveling. So, classification of crystal can be classified according to how they transmit plane polarized light. All crystal may be assigned to one of 5 groups, which correspond to the 7 system of crystallization. So, first, optical tropic crystal. These exhibit only one index of refraction for the light of each color. So, the second is optically anisexual crystal, which includes tetragonal, hexagonal, and rhombohedral system. This display double refraction and yield 2 refractive indices for the light of each color, one parallel to the optical axis and one perpendicular. So the third, optically Bsce crystal, all of which exhibit 3 principal refractive indices, one along each of the mutually perpendicular optical axis, in which 3 optical axes correspond to the 3 crystallographic axes. This is known as an orthorhombic system. So the fourth is optically Bsce crystal, in which only one of the 3 optical axes correspond to the crystallographic axis, known as a monoclinic system. So the last is optically Bsce crystal with no fixed definite relationship between the optical and crystallographic axis, a trilinic system. And thank you and God bless.
Hello and good day. My name is Bsce Gontinas, a student from Eastern Visayas State University or Moc City Campus, where I am pursuing a Bachelor of Science in Civil Engineering in Section B. In our subject Geology for Civil Engineers, I am assigned to discuss this topic about the chemical characteristics of minerals. What is the chemical composition of the Earth's surface? The crust refers to the Earth's surface. The majority of the Earth's crust is made up of oxygen. Silicon is the second most abundant building block on the planet's surface. There are several constituents, the most abundant of which is aluminum, followed by iron, calcium, sodium, potassium, magnesium, titanium, and hydrogen, and other chemical constituents. As a matter of fact, it is critical to identify the chemical structure of some minerals. Silicates are minerals that contain silicon and oxygen, 2 of the most abundant elements in the Earth's crust. Carbonates are minerals that contain the carbonate and ion in conjunction with other elements. Oxides are minerals that contain an oxygen and ion in combination with one or more metal ions. Sulfides are minerals that contain the anion sulfur combined with one or more ions. James Dwight Dana at Yale University developed a classification system for minerals based on chemical composition that has survived to the present day. He classified minerals based on their anions such as oxides, silicates, and sulfates. Minerals are defined in geology as a naturally occurring inorganic solid that has a specific chemical composition and crystal structure. It is relevant to know more about this topic because mineral resources are the foundation of the construction, manufacturing, and agricultural industries, and without them, industry would collapse and living standards would plummet. In addition, everyone uses mineral-based products on a daily basis. Even something as simple as a wooden pencil necessitates the use of a wide range of minerals. That would be all for this lesson. Thank you and God bless.
Good morning everyone, my name is Nicolai Villegas. I am a first year student, Bachelor of Science in Civil Engineering of Eastern Visayas State University. I am here today to discuss to you the origins and types of rocks. First, let's discuss the definite description of soil and rocks. Rocks are massive natural aggregation of minerals, grains of which cannot be easily separated from each other. Soils are also natural aggregation of minerals. However, they can be separated from each other easily by simple mechanical means. Next, we have rock forming processes. First, we have the crystallization of molten matter. This process involves the pre-existing partially molten state, which cools and crystallizes after coming in contact with cooler material. Second, we have weathering. Weathering is a term which is familiar to each of us. To have a short recall, it's the breaking or dissolving of rocks and minerals on Earth's surface. Once a rock has been broken down, a process called erosion transports the bits of rocks and minerals away. Lastly, we have diagenesis. Diagenesis is the process that describes physical and chemical changes in the sediments first caused by water-rock interactions, microbial activity, and compaction after their decomposition. Next, we have types of rocks. Volcanic rock, which is intrusive or extrusive. Sedimentary rocks, types of rock that are formed by the accumulation or deposition of minerals. Metamorphic rocks, formed when rocks are subjected to high heat, high pressure, hot mineral-rich fluids. Finally, we have the rock cycle. The rock cycle is the process by which rocks of one kind change into rocks of another kind. Each of these rocks can change into other kinds by physical processes such as cooling, melting, heat, weathering and erosion, compacting, squeezing tightly together, cementing, and pressure. Learning the basics of rocks and soil may be used as a foundation to learn more about geology through the course of civil engineering. In my first year in EVSU, I was hoping to gain new and exciting experiences as a freshman. However, the pandemic has constrained such excitement. Despite this, I have learned new things through our understanding and professional instructors. Learning through online classes is quite difficult for me, but I pray this pandemic will end for us to go back to our old norm. That will be all for today. Thank you.
Good day, my name is Faithy Carisi Ramos of Bsce 1B from EVSU OCC. My topic is Lecture 9, Origin and Types of Soil. Its objectives are to identify the origin and types of soil, composition of soil and constituents and structures of soil. The origin is from weathering parent material, volcanism, human action, and biogenic activities. The typical composition of soil mass are solid grains, pore fluids, and void spaces. Soil constituents are the following: minerals, water, and the structure. And there are two types of soil structure. These are the non-sensitive and sensitive or collapsible. Mineral constituents are the following: non-clay minerals and clay minerals. And there are characteristics of the soil, and these are composition, spatial distribution, behavior, and grain size. Soil types based on origin: residual soils from weathering bedrock, transported soils, chemical and biological soils, and lastly, volcanic soils. Engineering classifications of soils are based on grain size, organic content, and compressibility. And there are two types of weathering, for this is very common: mechanical weathering and chemical weathering. Geology is the study of Earth and the materials of which it is made. The structure of those materials and the impact of the characteristics, strength upon them is critical to respectful designing, since all work performed by respectful engineers include soils and its features. Fundamental understanding of geology is so imperative when planning a major construction that is maybe necessity in a university level civil engineering programs, for it must be understand the land upon which the project rests. Geologists and surveyors study the land to decide whether it is steady enough to support the proposed project. They moreover consider water designs to decide in a case in a specific location is inclined to flooding. A few respectful engineers utilize geologists to look at the rock, vital metals, oil characteristics of gas and groundwater. It was easy learning this lesson, even though it has a lot of terms and definition, but it was enjoyable, for it can be remembered easily. And also, it was short and informative. So that's all for this lesson. Thank you.
Hello everyone, I'm May L. Carmona from Bsce 1B. Now we are going to tackle about lecture number 10, which is igneous rock, under the Geology for Civil Engineering subject in Eastern Visayas State University. So before anything else, the viewers should be able to do the following. Describe main purposes for formation of igneous rocks. Second, classify igneous rocks based on their genesis and composition. Third, describe structures and textures of igneous rocks. And lastly, describe engineering problems and uses of igneous rocks. So what is igneous rock? Igneous rock is known as primary rocks and considered to be one of the most abundant rock here on Earth. So came from the Latin word fire and form when hot molten rock crystallizes and solidifies. So there are two compositions of magma. The first one is felsic and the second one is mafic. So felsic is usually light in color and have a specific gravity less than 3. An example for that is granite. While on the other hand, mafic rock is dark in color, high in iron, calcium, and magnesium. An example for mafic rock are basalt, diabase, and gabbro. So igneous rocks are classified based on texture and composition and divided into two groups, which are mainly extrusive and igneous rock. So extrusive rocks are fine-grained rocks that cools quickly on Earth's surface. So an example for that one is basalt, obsidian, andesite, dacite, rhyolite, pumice, scoria, and bromatite. While on the other hand, so intrusive igneous rock. So it is a coarse-grained rock that cools slowly beneath the Earth's surface. An example for that one is pegmatites, granite, diorite, and gabbro. So therefore, igneous rock is important, especially in the field of civil engineering, because this type of rock provides a strong foundation in construction, such as dams and reservoirs. It is also have a wide variety of uses in other fields of engineering as well.
Hi, I'm Francis Dene Ibanez, and I'm a first-year student at Eastern Visayas State University, or MOC City Campus, taking up Bachelor of Science in Civil Engineering. So for today, I will be discussing about sedimentary rocks for a subject which is Geology for Civil Engineers. At the end of this topic, you will know what is sedimentary rocks, its types, and also its classifications. So sedimentary rocks are a type of rock that were formed by the accumulation or deposition of mineral or organic particles of the Earth's surface. It has three types. First is the common sedimentary rocks. These rocks are often stored as sediments carried in rivers and deposited in lakes and oceans. Examples for this type of rock are limestone, siltstone, sandstone, and shale. Second is the clastic sedimentary rock. These are made of pieces pre-existing rock. Examples of this rock are the conglomerate, breccia, red sandstone, and gray sandstone. Lastly, the biologic sedimentary rocks. These rocks are formed when large numbers of living things die. Moreover, sedimentary rocks can be classified as non-clastic and clastic. When we say clastic, it forms from the mineral remnants of old rocks, volcanic ash, and biogenic ashes, and it is a non-clastic sedimentary rock if it is formed from an organic material or from chemical deposits. So this topic is just a piece of information you could add up onto your mind for future engineering purposes, which you can probably remember. And I remember this quote saying, "The larger the island of knowledge, the longer the shoreline of wonder." Thank you for listening. I hope we will meet each other, walking in the path we always wanted to step on.
Good day everyone, I am Vicente Duallo, a civil engineering student in section 1B at Eastern Visayas State University. So this video is related to our subject Geology and it topics about metamorphic rock. So in the end of this video, you will learn what is metamorphic rock and what is the relevance of knowing metamorphic rock. And since in high school, your instructor already topic about what is metamorphic rock. So this video will serve as a recall and to add up some understanding on what metamorphic rock really is and to know what is the importance of it in civil engineering. But before that, let's define first what is metamorphic rock. Metamorphic rocks. Any of a class of rocks that results from the alterations of pre-existing rock in response to changing environmental conditions. So those pre-existing rock will become a metamorphic rock due to the sudden change of environmental conditions. Metamorphic rock arises from transformations of rock to a new rock in a process called metamorphism. What is metamorphism? Metamorphism is the change of minerals or the geologic texture in pre-existing rocks. So that is the changing of protolith. Protolith means the term of the rock before it becomes metamorphosis. So metamorphism is the change in texture, physical chemical change of solid rock caused by the heat and pressure. So in other words, metamorphism is the change in the constitution of rocks. What are the examples of metamorphic rocks? First is slate, a fine-grained, foliated, homogeneous metamorphic rock derived from a regional shale-type sedimentary rock. Slate is composed of clay or volcanic ash through low-grade regional metamorphism. Next is the phyllite, a type of foliated metamorphic rock created from slate that is further metamorphosized so that very fine-grained white mica achieves a preferred orientation. Third is the schist, a medium-grade metamorphic rock formed by a metamorphosis of mudstone or shale, or some types of igneous rock to a higher degree than slate. It has been subjected to higher temperatures and pressure. Fourth is the gneiss, a high-grade metamorphic rock, meaning that it has been subjected to higher temperatures and pressure than schist. It is formed by a metamorphosis of granite or sedimentary rock. Those are the examples of metamorphic rocks. So whether it is an igneous rock, sedimentary rock or a metamorphic rock already. If it was subjected to heat and pressure, it will become a metamorphic rock. As what I've observed, the most commonly used metamorphic rock was marbles. Marbles are those that we use in our houses, like in the floors, decorative items like vases, figurines, or statues. As a conclusion, when taking a civil engineering course, we learn a lot when it comes to things that is related to geology. Also, it is crucial to know what are the types of rocks that we'll be using, especially when we're exposed to the field. And those rocks are important. Like, we know what are the rocks that we use in covering the floors, the rocks that will be used for the foundation of the buildings, the walls, and especially for the roofing materials and staircases. So that's all. I hope you learned something from this video. Thanks for listening.
Hi guys, I'm Instructed By. I studied a Bachelor of Science in Civil Engineering of Eastern Visayas State University. Today, we will discuss about weathering. Our country is a well-known tourist spot because it's a beautiful beaches and historical places. It also has plenty of rock formation that really amazing to look at. How you wondered how is rock are formed? True rocks seems to very hard, dense, and indestructible. This still break. The breaking of rocks into fragments is known as weathering. So, what is weathering? Weathering, that important process that helps shake Earth's surface. The breaking of rock results in the formation of soil in different platforms. That is also the reason we have amazing rock formation. So, what are the agents of weathering? The different agents of weathering includes water, wind, temperature, plants, animals, and human. So water can break rocks in different ways, like the soil in the riverside, which is broken by the pressure of the flowing water. The strong waves hitting the rocks can make it break. So wind is another agent of weathering that causes many beautiful rocks formation. As the wind blows, it carries sand or small rocks particles that scratch the rock's surface. How about temperature? The temperature, when rocks can expose the varying temperature, it expands. If rocks are exposed to a low temperature, it contracts. The repeated expansion and contraction of rock due to the change of temperature result weathering. So plants is another agent of weathering. Some plants like lichens, ferns, and mosses can also trigger weathering. It can grow on rocks and causes it to break into pieces. Trees can also trigger weathering. Its growing root can break the cemented ground. How about animals? The animals that live underground also contribute to weathering. As burrowing animals dig deeper, they cause rock break into pieces. Humans contribute to the weathering of rock subdivision. Developers use a bulldozer to flatten mountains or help build houses. Some construction workers use jackhammer to break boulders of rock as they repair roads. Mining companies extract stones or rocks from a quarry or open pit mine. It's because the mining activity can trigger landslide. Weathering can either be mechanical or chemical. Mechanical weathering is a physical weathering away of rocks without any change in their chemical nature. So how about chemical weathering? The chemical weathering involves change in the composition of rock that allow them to break into pieces. The surface continually change of the process that plays on around it. Remember, the breaking of rocks into smaller pieces is known as weathering. And the different agent of weathering includes water, wind, temperature, plants, animals, and human. Last but not the least, weather can be either mechanical, or chemical. And I hope you understand this video, and stay safe and God bless.
Good day everyone, I am Trisha Eldoria taking up Bachelor of Science in Civil Engineering at Eastern Visayas State University. And in this video, I will be discussing about sediment transport and deposition. So sediments, it is the conglomerate of materials. It is either organic or inorganic. It can be carried away through water, wind, or ice. Most mineral sediments came from erosion and weathering, while organic sediments are typically detritus and contains a decomposing material. One example is algae. Sediments are transported by various agents such as waves of the ocean, flowing water, submarine currents, meltwater streams that are originated from glaciers, and also ice. With these agents, the product of weathering gets transported away from the place where it is originally formed and gets deposited away from the location where it originated. Deposition of sediments. From the word deposition, it is the process of laying the sediments down, which is done by the carrying of the wind, water, or ice. The sediments can also be transported into pebbles, sand and mud, or as salt that is dissolved in water and then later on be deposited by organic activities or by evaporation. In addition, transfer by fluid action undergoes a physical process called lift and drag. And that would be the end of my presentation. Thank you for watching.
Hi, I'm Vicente Duallo, studying as first year college section B at Eastern Visayas State University. My topic was all about the introduction of subsurface exploration. The objective of this topic are the following: identify and delineate geologic units, describe the unit systematically, identify features such as joints, faults, leak inside, conduct sample index tests during exploration, assess hydrologic conditions, extract samples of geologic units and groundwater for laboratory testing, install instrumentation. The important highlights of this topic are the spacing and depth. It has a preliminary investigation, uniform subsurface conditions, highways, airfields, large dams, uniform subsurface conditions, highly variable subsurface conditions, exploration depth. The methods, it includes intrusive and non-intrusive methods. The spatial coverage, reflect the purpose of investigation, covers the project area, and cover an area outside of the perimeter if needed. The field doc, it contains the location and time of investigation, name of the personnel, and etc. The soil description, it includes the following: density or consistency, structure, field moisture conditions, color, odor, particle shape, and soil constituents. As a civil engineering students, it's very important for us to have all the knowledge about earthquake, hazard, and dangers at the construction site. It also reduces the cracking of the structure built in, and most importantly, to secure the people's safety. In my learning experiences, I gained a lot of knowledge that I can use for my course. There are things to be considered when building a structure and takes a long process. The study of geology has a lot of things to be learned and understand.
Good day everybody, I am Nefer Jefferson Safra Rojas from Bsce 1B, currently studying at Eastern Visayas State University, Ormoc City Campus. For today's video, I am going to discuss one of the topic in our subject Geology, which is Lecture 16, Subsurface Exploration. Our learning objectives is to identify what is subsurface exploration, to know what is purpose of subsurface exploration, subsurface exploration program, and the methods of subsurface exploration. What is subsurface exploration? When we say subsurface, it is something that is below the layer on the surface, while exploration is an act of exploring or investigating. Basically, subsurface exploration is a process of identifying the soil deposits that underlie the proposed structure and their physical characteristics. Purpose of subsurface exploration are the following: selecting foundation type and depth for given structure, evaluating load-bearing capacity of the foundation, estimating probable settlement of the structure, establishing construction methods and for changing subsoil conditions, and lastly, determining potential foundation problems. And now, let us move on to Sub-3 Subsurface Exploration Program. First is the collection of preliminary information, which includes topographical maps, aerial photographs, and geologic maps. Second is the reconnaissance of site visit, which includes off-site condition and their impact, soil, rock at the surface, performance of nearby structures. Then lastly is the site investigation, determining the ground condition and geologic structure. Next is 3 methods of exploration. First is open excavation. In open excavation, there are 2 ways, which are pits and trenches, then drift and shaft. Next is the boring methods. Some of the types of boring methods are wash boring, auger boring, rotary drilling, and percussion drilling. Lastly, the geophysical method, which includes underwater scuba radar, microgravity, electromagnetics, and seismic measurements. Through this lesson, I have learned that it is important to know about the material below in the ground surface before constructing on it. So, know before you trust. That's all. Bye-bye.
Good day. My name is Margie Molina and I'm currently taking up Bachelor of Science in Civil Engineering in Eastern Visayas University. And today we will discuss the topic entitled Non-intrusive methods. It is a method available to archaeology which helps to investigate, identify, and record archaeological sites and features without damaging potential archaeology. Non-intrusive methods are the following. So first, we have the field walking. It is a systematic recovery and recording of artifacts found in the surface. Then we have the playing table surveying. It is a graphical method of survey in which the field observation and plotting are done. Then we have the electric distance measurement or EDM. It is a method of determining the length between 2 power using the electromagnetic waves. Global Positioning System or GPS. It helps you get where you are going. Geophysical surveying. A ground-based physical sensor technology used for archaeological imaging or mapping. Resistivity. It is used to detect and map subsurface archaeological features and patterning. Magnetometry. It is a scientific tool that measures magnetic properties. It also reveals the soil layers and the buried structures. Ground penetrating radar or GPR. It is used to investigate underground utilities such as concrete, asphalt, pipes, metals, and many more. And lastly, we have the geochemical surveying. It is a survey involving chemical analysis of a systematically collected samples of soils, rocks, plants, or water. With the help of the non-intrusive method as a civil engineer, we can now locate, identify, and understand and record archaeology without damaging potential archaeology. Because civil engineering structures are made from different materials, or animating of methods are all fulfill requirements with respect to the fire behavior and to the fire resistance of when the building will last. So, as an aspiring civil engineer, building must be designed carefully so they will remain safe during working life. That's all. Thank you.
Good day everyone, I am Marjorie Impilande under the GU122 of CE1B in Eastern Visayas State University. So today we are going to talk about the index property and classification of soil. In the end, if you sink into it, you will be able to learn the essential factors governing engineering of soils, the index property of soils, understanding the classification of soils considering particles, size, and plasticity, the properties of three phases, materials, and lastly, estimate major indices that govern soil behavior. So, what is soil? Soil are the complex mixture of minerals, water, air, organic material, and countless organisms that are decaying remains of once living things. It is an unconsolidated mineral or organic material on an immediate surface of the earth that serve as a natural medium of growth of land plants. Soil has three minerals, namely clay, silt, and sand. However, there are various index properties of soil. These are the following. So, water content, specific gravity, in situ density, particle size, consistency, and relative density. The purpose of a soil classification system is to group together soils with similar properties or attributes. From the engineering standpoint, it is geotechnical properties such as permeability, shear strength, and compressibility that are important, while index properties are those properties which are not prime importance for the geotechnical engineering but are indicative to the engineering properties of soil such as bearing capacity, shear strength, permeability, slope stability, compressibility properties, and so on. I feel so brainly when I learn this. So as aspiring civil engineering student, we must be aware of the soil classification and index properties for the planning and designing of a project.
Hello, good day. My name is Maria Rosamarel from Eastern Visayas State University, taking the course of Bachelor of Science Civil Engineer, and for this subject of Geology, we are talking about the Lecture 19, the index properties of rock and the rock mass. For this lesson, we will be able to list the essential factors governing engineering behavior of intact rock specimen and the rock mass, and estimate the major indices that governs behavior of the rock mass, and lastly, classify the rock mass. The properties of a rock according to the classification system recommended by the International Society of Rock Mechanics. And the rock may range from extremely weak to extremely strong, depends on the unconfined compressive strength or point load strength index or approximate field identification. And also the specific gravity of soils, permeability, the porosity, the density strength, the compressive strength, the tensile strength, elastic modulus, ultrasonic velocity, and etc. So the rock type density, which is the grams per cubic centimeter, are the quartzite of 2.65, the salt, which is 2.10 to 2.20, the sketch the stress 2.73 to 3.19. The shell is 2.6 to 2.67. As you can see, the one of the heavier minerals is gold has a density of 19.32. Porosity and permeability. Porosity are related properties of any rock or loose sediment. Most oil and gas has been produced from sandstone. These rocks often have high porosity and are usually high perm too. Wow! Porosity consists of the tiny spaces in the rock that holds the oil or gas. Permeability is a characteristic that allows the oil. Porosity consists of the tiny spaces in the rock that holds the oil or gas. Permeability is a characteristic that allows the oil and gas to flow to the rock. So, as you can see at the picture, no pore spaces. There are three spaces: the no pore spaces, the uncontented pore spaces, and the connected pore spaces. And no pore spaces, the rocks are compressed to each other. The unconnected pore spaces, the rocks are separate to each other. And the connected pore spaces, the rocks are separate to each other. So these are the porosity ratio of void is equals to the void or pore volume over to the total volume, which is the V. So in that case, we apply the small axial load compressive on the specimen, and as a result, the length of specimen is going to be shortened. The axial stress is going to move in that case. When it continued to compress, the result will be going to be yet varied.
And as I've learned, my learning experience in this course as a student of engineering, I will be able to recognize my experience during this pandemic. And as I've learned to this subject, practical knowledge is very important in this discipline. For civil engineer, the basic purpose of study in geology is to get to know about properties, the characteristics, and behaviors of soil and rocks, so that problems which a civil engineer design a building on different soil condition can easily be mitigated with the help of studying the subject of geology.
Good day, I am General Tumada Toyong, and I am about to discuss the stress-strain behavior of soil rocks. So stress at a point. There are two types of stress, the normal stress and the shear stress. When we say normal stress, it is a force that acts perpendicular to the surface of an object. with a formula of sigma is equal to the force over area, wherein our F here is our normal force. And as for the shear stress, it is when a force acts parallel to the surface of an object, with a formula of tau is equal to the force over the area, wherein our F here is the shear force. There are also types of normal stress, the tensile stress and the compressive stress. When we say tensile stress, it is the normal force per area that causes an object to increase in length. So for example, this is our object. The force applied here is tensile, meaning the object is under tension resulting to the increase of its length. While compressive stress, on the other hand, is the normal force per area that causes an object to decrease in length. So this is our object. The force applied here is compressive, meaning the object is being compressed, resulting to decrease in length. So stress tensor. So why is it that stress is a tensor and not a vector as well as a scalar? Because in case of a scalar, there are no orientations, and as for the vector, there is only one orientation, and as for the tensor, there are two orientations, and one of those orientations are the directions in which the force are acting. This will tell whether it is a tensile or compressive stress, and the other is the orientation of the plane on which these forces are acting, and it will tell whether that stress is shear or normal. So next is the strain. There are also two types of strain, the normal strain and the shear strain. The normal strain is a term that describes the response of a solid to the application of a normal force. That is, a force that is perpendicular to the object cross-sectional area. This property can be defined with a formula. The epsilon is equal to the change in length over the original length. And as for the shear strain, it is the ratio of the change in deformation to its original length perpendicular to the axis of the member due to the shear stress, with a formula of epsilon is equal to the delta x over the length. So once again, I am John Ranel Toyong, and that will be all. Thank you.
Okay, hello, good day. So, lecture 23 is about geologic considerations in tunneling. So, first, what are tunnels? So, these are underground passages or routes that is open at both ends and constructed for different purposes. So, in tunneling, we have here the geological considerations or the ground properties. So, there are 4 geological considerations in tunneling. First is types of rock, second is geological structure, third is groundwater condition, and last is overbreak. So, first is the types of rocks. So there are 3 types of rock. First is igneous rocks. These igneous rocks are competent but difficult to work with, and also igneous rocks do not require any lining. So next is the sedimentary rocks. So sedimentary rocks are less competent than igneous rock, and this is soft and easy to work with. So the last types of rock is metamorphic rocks. So gneisses are similar to granites in these rocks. Okay, moving on to the second geological considerations, which is geological structures. So there are 4 geological structures. First is the effects of joints. Most of the rocks in nature possess irregular cracks and regular joints, which are plain of complete separation in rock masses and clearly represent weakness in them. That is why it's very important to consider this in tunneling. Next is effects of faults. So as in civil engineering projects, other civil engineering projects, in tunnels too, faults are harmful and undesirable because they create a variety of problems. These faults lead to dislocation and discontinuity in the tunnel alignment. Next, followed by the effects of faults. So, faults represent the deformation of rocks under the influence of tectonic forces. And last is the effect of tilted strata or undisturbed. In cases of horizontal and gently inclined beds, conditions will be favorable for tunneling. Next is groundwater condition. So first is tunnel access passing entirely through impervious formation. So the tunnel access may be passing entirely through impervious formation, and this is an ideal condition for tunneling because there is no possibility of water leakage or movement, but this is very rare in nature. Next is tunnel access mostly above the water table. So the tunnel access might be located mostly above the water table, intercepting the aquifer only some sections. So tunnel access mostly above the water table. And lastly, tunnel access below the water table. Such a situation should be avoided as far as possible in some specific cases. However, this might be the only possibility, such as in soft ground tunneling and underwater tunneling below rivers and lakes or in water-karst region. Last is overbreak. So, it is well known that overbreak caused by the blasting damage during tunnel excavation. So, this increases cost associated with filling the collapse area with shotcrete and result in filling of the claim by contractor.
Good day, I am Lawelyn Bsce, first year college from Eastern Visayas State University, taking up Bachelor of Science in Civil Engineering, Section B, and I will be talking about geology considerations in dam constructions. So dam is a structure built to retain water. It is a barrier that stops or restricts the flow of surface water or underground streams. Dams are built to provide water for human consumption, for irrigating arid and semi-arid lands, or for use in industrial processes. It has different types with different features. And there are many geology considerations that we need to consider when constructing a dam, like the condition of soil or the foundations, the site where to build the dam, the loads, and the failure modes. And these geology considerations are important to look since it helps us to build a stable dam.
We all know that the earth is full of water, but there's a lot more water than all the blue stuff you see on the globe. Hi, I'm Matthew Stenmiro, first year civil engineering student of Eastern Visayas State University, Section B, and this is lecture 25 of this geology lecture series, which is all about groundwater preliminaries. The objective of this lecture is for us to describe what is groundwater, describe the water cycle, list the sources of groundwater, and define the important terms used in hydrogeology. As I said a while ago, the earth is full of water, but there's a lot more water than the seas, lakes, ponds, and rivers that we commonly see. The water that we can see on the surface of the earth is called the surface water, while the water in the ground below your feet is called the groundwater. Groundwater is water that's formed in the tiny gaps between rocks, soils, and sediments under the ground. it fills pores and fractures in underground materials such as sand, gravel, and other rock, much the same way that water fills a sponge. A full body of groundwater is called an aquifer. An aquifer is an underground layer of water-bearing permeable rock. Rock fractures or unconsolidated materials such as gravel, sand, or silt. Now, there are two types of aquifers, the confined and unconfined aquifers. Unconfined aquifers are those into which water seeps from the ground surface directly above the aquifer, while the confined aquifers are those in which an impermeable dirt or rock layer exists to prevent water from seeping into the aquifer from the ground surface located directly above. Then next is the water table. The water table is an underground boundary between the soil surface and the area where groundwater saturates spaces between sediments and cracks in rock. A seep, spring, and stream are groundwater that reaches the ground surface from an underground aquifer. So how does all this water end up in the ground? So mainly there are three main sources of groundwater: the meteoric, connate, and juvenile water. The first and most common is the meteoric water, which is a byproduct of the water cycle. It originates in the atmosphere by evaporation, which falls as a rain and ultimately becomes groundwater with the process of infiltration. Second is the connate water. It is also known as fossil water, which refers to the liquids trapped within sedimentary rocks. Then lastly is the juvenile water, that is also known as magmatic water. With the cooling of the magma, its gaseous contents and water vapor separate from it. So that concludes the lecture 25 about groundwater preliminaries. Thanks for watching and I hope you've learned something in this video. Thank you.
Hello, good day. I am Ronald Imping. I'm a first-year student of Eastern Visayas State University, Ormoc City Campus. I am a Bachelor of Science in Civil Engineering from Section CE1B. I am going to discuss groundwater flow from our subject Geology for Civil Engineers.
Objectives: learn about groundwater flow, understand how groundwater flows, know the relevance of groundwater flow to civil engineering. Groundwater flow. It is a flow of water from underneath the ground in response to elevation differences downwards and pressure differences from areas of high pressure to areas of low pressure.
So, nature has created a complex underground system that collects and stores our groundwater. All groundwater was once rain or snow. Rain and melted snow soaks into the ground, moves through the soil and the rock beneath our feet, and eventually, over days, weeks, or years, may flow naturally to a spring or field, or be pumped from a well for drinking water. The water we drink is not stored in connected spaces within sediment and rock. These layers of sediment and rock that hold groundwater are called aquifers. Groundwater contained within aquifers can move downward due to gravity, sideways due to different rock properties, and upwards due to pressure. Predicting where groundwater will go is not easy because the various layers of sediment and rock influence the water's path. So, groundwater is found beneath the Earth's surface in soil pore spaces and rock formation fractures. The flow of groundwater below the surface is a fundamental property that controls the strength and compressibility of soil, impacting soil's ability to hold up on structural loads. This topic helps engineers try to understand the groundwater flow and on how water flow affects the soil underground as it also helps on the study of the ground if it is safe to work on. That's all for groundwater flow. I hope you liked it. Have a good day.
Good day. I am Ana Jane Custodio, first year student of Bachelor of Science in Civil Engineering at Eastern Visayas State University or Moc City campus. My topic title for today will be the groundwater flow part 2, which holds a discussion about the aquifers, the confined and unconfined aquifers. The objectives of this topic title will be the difference between the two and the relevance of these aquifers to civil engineering. Aquifers can be classified into two: unconfined aquifers and confined aquifers. First, unconfined or open aquifers are directly connected to the Earth's surface. In contrast, confined or closed aquifers are separated from surrounding rock layers by confining units above and below the aquifers. Confined aquifers are supplied by water that filters down from the land surface. It is much like pouring water into a breaker of gravel. The water easily flows between the grains, and the level of water in the breaker is dependent upon the water supply. The water table represents the upper surface of an unconfined aquifer. The greater the water supply, the higher the elevation of the water. We expect the water table to show some short-term fluctuations related to storms and long-term seasonal variations. There is also the potential for a decline in the depth of the water table if and only if groundwater is consumed more rapidly than it is replenished. On the other hand, confined aquifers water doesn't enter as easily as it does in unconfined. Water can just trickle down into the aquifer, but the underlying confining layers prevents water from flowing directly into the confined aquifer from above. Instead, the aquifers are supplied by stream flows or precipitation in places where the aquifer's material crop out at the surface. Groundwater flow in a confined aquifer is under pressure from water upslope in the same layer. So this can produce artesian wells that shoot up the pressured water upward that there's no pumping needed. This topic helps the engineers to understand the difference between the confined aquifer and the unconfined aquifer so that they will know what to do before the construction of water wells. That's all for today. Thank you.
Hello, my name is Ana Nicole Arquezada. I'm a student of EVSU or MOC under Bsce 1B. So today, I'm going to make a brief discussion about a certain topic in geology for civil engineers. So our objectives include develop groundwater control plan to facilitate excavation, qualitatively assess the potential for erosion due to groundwater movement and the potential for landslide, and lastly, identify measures to control seepage and contaminants. Groundwater-related engineering issues have been an account to what causes failures among construction, which particularly includes underground erosion and contaminants from agricultural, industrial, and municipal. To potentially avoid these problems, we have resorted to methods of dewatering or drying up the land before any necessary excavations. So methods of dewatering discussed are well point method and drawdown control. So fortunately, the dewatering process ensures that the soil is dry prior to excavation. So pumping removes excess water on the ground surface and underground, which will help firm up the soil. If it is done properly, dewatering prevents soil erosion and upheaval failure.
So welcome to this video. I will introduce to you my topic about groundwater utilization. First, let me introduce myself. I am Rex BG Idoy from EVSU Armagh, and I am a first year civil engineering or Bachelor of Science in Civil Engineering. My topic is all about groundwater. So let's talk about groundwater. The objectives of groundwater utilization that I think it was. So first, the first objective it was to learn the effect of groundwater utilization or depletion of water in the ground. Secondly, to know groundwater depletion as a part of or related to the course. And lastly, to have a view about how groundwater utilization is, or how the water depletes in underground or below the surface. The topic groundwater utilization. So first, we need to know what is groundwater utilization. So groundwater utilization, if we talk about it, that implies if we utilize an aquifer, we remove a certain volume or sensible volume of a groundwater. And these changes also affect the recharge and discharge data or natural way of natural something like natural phenomena that happens underground or under because of pumping results. The artificial discharge of an area and its suppression may be effectively we reduce or the recharge or the discharge amount will effectively be reduced and the net value will equal to zero. So let's talk about hydraulic dredging. So hydraulic dredging is referring to human interventions or the humans controls the flow of groundwater. So like healing or depending on the place, we recharge water from the neighboring aquifers or some like hilly place or plains. It depends on the place where groundwater is. So that's in this kind of the way we, in this kind of recharging a groundwater, we like borrow some water to another aquifer or neighboring aquifer, but that's according to some kind of studies, or that's a geophysical or hydrological something thing studies or some kind of thing like there too much use pumping usage. I don't know that they already exploit a natural resource or because of exploiting groundwater resource, the dams and lakes, or we can see the effect the lakes and some kind of water aquifers or something snow depleting. Some areas may have seem like semi desert areas. There are some kind of that depletes entirely out of water. So it is just a shallow groundwater. That's it. The drying up of wells, drying up of rivers, or some kind of water bodies or small water body. The pumping costs, the impacts varies on the pumping usage or how fast the pumping is. So there are some kind of impacts like saltwater intrusion, destroying natural habitat of some kind of animals, maybe or some kind of animals area. Also, maybe land subsidence. The land will subside because there is support for groundwater, but that area will not flow or flow to the base flow, or not directly flow to the base flow, something like that. Like we built a tunnel or something, or in irrigation. We don't know how
Today we did encounter that kind of water. We know how groundwater works, systems that groundwater or base flow works, to understand better how hydrology works in some kind of fields like agriculture. Well, it's not just buildings or something like that. Because buildings needs to support plants and such buildings need supports. So we know how to deal with groundwater, because buildings are also uses create something like buildings or something like that. Yes, amount of water. And then I feel like I learned something like more important than this stuff, or learn something new, something like never expected to learn. And this would be a lesson for me person.
Good day, everyone. I am Bsce Rose D. Inoho, a Bsce 1B student of Eastern Visayas State University. Our subject is all about geology for engineers. And in this video, we're going to tackle about plate tectonics. So before we start, we have here the objectives. First, we're going to define what is plate tectonics, determine what are the types of tectonic plate movement, what causes tectonic plates to move, and how many tectonic plates are there, and lastly, how do tectonic plates works. So now, let's start. Okay, so what is plate tectonics? Plate tectonics describes the large-scale motion of the plates. Now, who is Alfred Wegener? Alfred was the one who noticed that the coastlines of several continents looks like a puzzle. Moving on to the three main layers, which is the crust, second the mantle, and third the core. First, we have here the crust. Crust is the outermost and thinnest layer of the earth. Crust has its own two major parts. First, we have continental crust, which is the elevated portion of the earth, and oceanic crust is the ocean bed. Another layer of the earth is the mantle. Mantle is located below the crust, and it's also considered crust. And lastly, we have the core, and the core is also divided into two. The outer core, which is composed of nickel and iron melted by intense heat, and the inner core composed mainly of solid iron and nickel. Now, at this time, we are now in the three types of plate boundaries. First, we have divergent boundary. Second, convergent boundary. And third, transform boundary. So, divergent boundary occurs when two tectonic plates move away from each other. Second, the convergent boundary occurs when two tectonic plates collide with each other. And transform boundary occurs when two tectonic plates slide away. It is very important to study plate tectonics for us to know why plates are come together, spread apart, and interact. It is very interesting, and I'm very amazed why tectonic plates are moving, because it is like our journey. It is continuously moving and many things change. So I think that would be all. Thank you and God bless.
Good day, everyone. I am Athena Paula Larius from Bsce 1B. The lecture 31 on the subject of geology talks about the plate tectonics and earthquakes. This lesson aims on how to identify the characteristics of convergent, divergent, and transform boundaries, describe the evolution of continents, and list the types of the seismic waves. There are 5 evolutions of continents. These are the Permian period, the Triassic period, the Jurassic period, the Cretaceous period, and the present. Plate boundaries are classified into three: the convergent, divergent, and transform boundaries. An earthquake is a trembling of Earth's surface caused by a sudden release of energy in the Earth's lithosphere. Seismic waves are classified into two: the body waves and the surface waves. In earthquakes, it also talks about the magnitude that the energy released at the source and the intensity that the impact on people, structure, and the surroundings. When it concerns to earthquakes, an engineer will always tell you that it is always better to be safe than sorry. Engineers examine the impact of plate tectonics on construction projects, particularly those near active faults and coastlines. When one tectonic plate suddenly moves relative to another, the energy can result in earthquakes that damage structures. Engineers must first understand the qualities and behaviors of ground and subsurface materials in order to construct suitable foundations. They build structures with enhanced safety features to cater for the expected magnitude of earthquakes in these places.
Good day to each and everyone. The lady speaking in front of you is Ms. Lily Mindaha Magdalaga, a first-year college student taking a Bachelor of Science Civil Engineering at Eastern Visayas State University. I'll be discussing about
Earthquake hazard assessment.
But before I proceed, these are the following objectives for our discussion. Structures must be ready for upcoming natural disasters or man-made disasters, such as earthquake, and it can be possible with the help of earthquake hazard assessment. Because before engineers build the structures, an earthquake hazard assessment is done and used by them to make sure that the site is good enough to avoid damaging impact of earthquake, and it can build sturdy and safe structures for everyone.
These following are methods to identify the sources of an earthquake.
The USGS seismic hazard maps are used to evaluate the seismic hazard across the country. They are linked to various components of earthquake risk, such as ground shaking and crustal deformation. The increasing number of earthquakes in the country has highlighted the need to improve the built environment's resistance to seismic activities. Understanding the various effects of earthquakes on the built environment requires the development of tools and techniques that can be used by design engineers. And these are the seismic hazard assessment objective, principle, and procedure. There is no seismic risk map exists for the world present, and the value of such maps is questioned. So, they can begin by analyzing earthquake prediction in terms such as earthquake hazard, exposure time, and restore time. And this topic also talks about earthquake aspects of risk assessment, which can be done with the help of data and methods. The calculation of seismic risk should be performed probabilistically, although critical structures are most likely to be damaged than non-critical ones. Their design should be considered with estimating seismic risk.
These following are some ways on how engineers handle an earthquake.
How essential earthquake hazard assessment to engineering? Well, an earthquake are unlike many of the other problems that structural engineers deal with. There are technical considerations to be made. Unlike hurricanes, earthquake shocks the structures and surfaces of the building from both inside and outside. One of these common characteristics is that the resources spent to recovery following a large-scale natural disasters frequently much outnumber those allocated to mitigation measures prior to the event. To sum up this report, this topic helped me a lot in understanding that engineers use earthquake hazard assessment for them to build structures with the right standard from earthquake impacts. Civil engineers are very concerned about the safety of the land they're going to work in. Doing so is very important for them as it will affect the safety of everyone, the money they'll spend, and the efforts they put in. And that would be all for the earthquake hazard assessment. Thank you.
Hi sir, good day. I am Jake Guillermo Monreal from the Bachelor of Science Civil Engineering Section 1B, and I'm currently studying at EVSU, or the Eastern Visayas State University. And in this video, I will be discussing the Geology 1 to 2, which the topic entitled the lecture 33 Geologic Hazards, Seismicity and Volcanism. The objective of this topic are to define what seismicity is and where is it related to, give a brief explanation on how earthquake works, and evaluate what induced seismicity is and how and why does it occur, define what is volcanism is, and explain how and why does it erupt and what causes it to erupt, evaluates the areas where the volcanism mostly takes place, and knows the various parts of the volcano, understand the different types of volcanoes on the basis of its activity, eruption and external structure, and explain the various volcanoes' hazardous and its negative and positive effects during and after the eruption. The highlight of this topic are the volcanic eruption, positive and negative effects. So yeah, as you can see in the picture or in this picture, these are the positive and negative effects of the volcanic eruption. So yeah, just look at it and read it. Well, for me, this topic is very important to know as an engineer or as a civil engineering student, because the earthquake is one of the threat on us engineers, because it will test how the buildings we built will easily fall down, or how it will be strong enough to handle the shaking that will happen. And this topic is relevant to know where are we going to build something that's strong so it will not be destroyed if there will be an upcoming or we don't know if there will be earthquake that will happen. We just need to be ready so that it will not be destroyed. Well, for me, I'm happy and blessed because God guide and lead me here in civil engineering. Well, about this course, I've learned a lot on how this course is important in engineering, because through this topic, you will learn the environment's place, where to build something that is strong, and many more. And I've also experienced all throughout this school year, I felt happy, have fun, and it's very memorable. It's knowledgeable, and most importantly, I learned new things. So yeah, that would be all. Thank you.
Hello, I am Maria Daisy Ana Binuha, a student from Eastern Visayas State University, Ormoc City Campus, class Bsce 1B. In this video, from the subject Geology for Civil Engineers, we're going to tackle the geologic hazard, shoreline processes. Now, our objective here is the principal causes and consequences of shoreline hazards, discuss tsunami and earthquake, and to look for the relevance of this topic to engineering. A tsunami is a series of sea waves characterized by very long wavelength and period. It is generated by the sudden change in sea level, which is caused by underwater earthquakes resulting from the movement of subducting tectonic plates. The upward jolting of the movement of a tectonic plate can lift the several kilometer thick layer of water above it, causing a gigantic wave to form and travel for thousands of kilometers, carrying the energy of the earthquake across the ocean until it reaches the coast. Unlike wind-generated waves, tsunamis affect the body of water in a given section of the ocean, meaning that the entire water column, which can be several kilometers thick, moves out vertically in a given part of the ocean, while the wavelengths of wave-generated waves range between 100 and 200 kilometers in a 5 to 6 kilometers deep open sea. If the depth of the sea is far less than the wavelength, the speed of the wave determined by the depth of the water. Therefore, the tsunami travels at a speed of around 800 kilometers per hour in the open sea, which is the equivalent of an airline speed. However, wave heights do not exceed 1 meter, so ships do not even notice them. The dumping of waves is inversely proportional to the wavelength. A tsunami can therefore travel thousands of kilometers with the minimum loss of energy. Its speed significantly decreases the shallow water near the coast. It slows down to 80 kilometers per hour in 50 deep water. Since its energy is constant, it piles up high and higher, and eventually, when it hits the coast, the devastating tsunami can be tens of meters high. A number of waves can follow one another with a period of 10 to 20 minutes. To conclude, a thorough and accurate knowledge inventory of geology is an essential part of construction and hazard assessments. The landslides, earthquakes, and tsunami must also be found correctly and plotted as polygons representing their true forms. Advances in technology and geology understanding have made civil engineering projects more accessible and high resolution to detect in recent years. An earthquake, as well as a fast fall or increase in coastal waters, might indicate the advent of a tsunami. Earthquakes are an inevitable natural danger, but they may be mitigated with appropriate planning and a well-informed and prepared population. Because of geologic expertise, dams, tunnels, reservoirs, and other civil engineering projects are built with safety in mind and with materials that are more stable, durable, and cost-effective.
Hi, Hazel National Bsce, currently studying Bachelor of Science in Civil Engineering at Eastern Visayas State University. So, without any further ado, this short video presentation is all about geologic hazards, shoreline processes, and at the end of this video, we will be able to know the following objectives, and these are: what is shoreline erosion and deposition, and what causes it? And lastly, mitigation strategies. Coastal erosion is the loss or displacement of land, or the long-term removal of sediment and rocks along the coastline due to the action of waves, currents, tides, wind-driven water, waterborne ice. Natural causes of coastal erosion: first is breaching and overwash, while second is transport to the dunes, and third is offshore sand loss under extreme wave and storm surge conditions, offshore sand loss to canyons, offshore transport at the tip of sand spit, and erosion downstream of accumulative forms. So here are the mitigation strategies. First is groin. It is used to maintain upward beaches or to restrict longshore sediment transport. And second, breakwater. It is a structure constructed for the purpose of forming an artificial harbor with a basin to protect from the effects of waves as to provide safe berthing vessels. And lastly, mangroves. Mangroves is to protect shorelines from damaging storm and hurricanes, winds, waves, and floods. Mangroves also help prevent erosion by stabilizing sediments with their tangled root systems. They maintain water quality and clarity, filtering pollutants and trapping sediments originating from land.
Here are some facts about mangroves that you need to know.
Hi, I am Judian S. Mpat, a Bachelor of Science in Civil Engineering, Section B student in Eastern Visayas State University. We are assigned to make a video summary of our reports in our subject, Geology for Engineers, and I will be discussing some important highlights about landslide. So first, what is a landslide? A landslide is defined as the movement of a mass of rock, debris, or earth down a slope. Landslides are a type of mass wasting which denotes any downslope movement of soil and rock under the direct influence of gravity. Landslides are the most costly geohazard in the world, and are often the cause or the result of other hazards and disasters such as tsunamis, earthquakes, wildfires, and volcanic eruptions. What is landslide hazard zoning? The landslide hazard zoning is the process of classification of land with equal landslide hazard value. Why do landslides occur? A landslide occurs because the force of gravity becomes greater than the internal strength of the rock, soil, or sediment. What are the causes of landslide? Landslides may be caused by snowmelt, rainfall, water level changes, groundwater changes, stream flooding, volcanic activity, earthquakes, intrusion by human activities, or any other factors that make the slope unstable. What are the positive and negative effects of landslide? As with all natural hazards, landslides offer some important service functions. Thus, the positive effects of landslides are creating new habitats, increasing biodiversity, providing raw materials, and can be good tools for studying the environment. The impact of a landslide can be extensive, including loss of life, destruction of infrastructure, damage to land, and loss of natural resources. There are various direct methods of preventing landslides. These include modifying slope geometry, using chemical agents to reinforce slope material, installing structures such as piles and retaining walls, and rerouting surface and underwater drainage. How is studying landslide relevant to civil engineering course? Different engineering infrastructures lie on geological bases. During engineering practice, the penalties for geologic mistakes can be severe. That is why the study of geology, including landslide hazard zoning, is very important in this course. For us to enable a durable and sustainable engineering structures and to also avoid accidents that may lead to the loss of life, either human or any other living organisms. Now that would be all. Thank you for watching and listening.
Good day everyone, my name is Jampol Espratelia. I'm a civil engineer student of Bsce 1B in Eastern Visayas State of University. I will tackle about our subject in geology. The topic is Geologic Hazard Subsidence, Collapsible Soil, lecture number 37. Objectives: identify subsidence hazard due to subsidence, swelling and collapsible soils, and list typical mitigation measures. What is geologic hazard? It's one of several types of adverse geologic conditions capable of causing damage or loss of property and life. Subsidence is the sudden sinking or gradual downward settling of the ground's surface with little or no horizontal motion. What causes subsidence? It is underground opening like longwall mining, room, and pillar mining. The longwall mining is a fast allowed to develop in a controlled manner, usually during operation. Room and pillar mining is a fast may develop long after end of mine operation, often in an unpredictable manner. Impacts of subsidence. So these are the example: sinkhole and through or sags. So the sinkholes is a caused by upward migration of voids after roof collapse of an underground cavity, often accelerated by groundwater erosion, and may develop violently. Troughs or sags is a cause when the roof of a large underground opening collapses and usually develops slowly. So these are the mitigation strategy. Identify underground cavities. Prediction like longwall mining. Avoid or evacuate hazardous areas. Structural measures like backfilling or grouting, absorb compression, perimeter trench. And the last one is observe differential settlement like flexible utility connections. This picture is the sample of shrinking and swelling. It's also called shrink swell. It's the volume change that occurs as a result of changes in the moisture content of clay-rich soils. Swelling pressures can cause heave or lifting of structures, while the shrinkage can cause settlement or subsidence, which may be differential. What causes shrinking and swelling? Water contained in the near surface, type of soil, clay's propensity to change volume. These are the control strategy for shrink and swell. Extend building foundation to a deep where they are below the zone of water contained fluctuation. Remove the pre-existing expansive soil and replace it with a non-expansive soil. Soil stabilization. The last one is the assess engineering behavior test of mineralogy, free swell potential, and Antrenberg limits. This picture is a collapsible soil, also known as loess. It is basically a clayey silt with a metastable structure. Collapsible soil shows high strength and stiffness at normal water-contained conditions. These are the properties of collapsible soil. An open metastable structure, a high voids ratio and low dry density, a high porosity, and the last one is a soil with inherent low interparticle band strength.
As a civil engineer student, so I learned that the geologic hazard subsidence and collapsible soil, we must be a preparedness to the location if we build a building or a house, and also to all construction of public facilities should have proper subsurface testing and evaluation done before bidding takes place, and supervision of the site during the building piece or construct to the location. Then, I have a mitigation strategy of collapsible soil. The first is soil replacement. The second is chemical stabilization. The third is pre-weighting. And the last one, the fourth, is select suitable foundation.
So that's all. Once again, my name is John Paulus Padilla, Section Bsce 1B. Thank you for listening my discussion this day. God bless us all. Bye-bye.
Good day everyone. I am Raul C.H. Engineer from Bachelor of Science in Civil Engineering, Section 1B in Eastern Visayas State University. So today, we will have a brief discussion about the preparation of Geology section, Lecture 38. Take note that this discussion is based on a straight line. So, first, we must know what is Geologic section and a straight line. So, a geological section is a graphic representation of the sequence of rocks or of the geological structure of the study area. It generally shows the course of beds and tectonic lights in a vertical plane. For drawing geological section, we need to know the form of land surface in the section line and pertinent that geological data. A straight line is a straight line joining the intersection between the line on a geological map separating the outcrops of the two different geologic units and topographic contour of the same elevation. So now, I will show you an example to know better what is a straight line. So, this picture, it is an example of a geological map. So we can find the straight lines in here, near in the middle, the line that connects the two dots. Next, I'll show you an example of a geologic section. So in this picture, in the lower part, you can see a small piece of a geological map. So, and the upper part is the geological sections. So now, I'll show you the steps in preparation of geologic section.
Good day everyone, I am Eunice Mercanis Lacno from Bsce Section 1B. So here, I will be going to discuss the demonstration and the different simple laboratory testing for classification and identification of key soil parameters and the rock parameters. So, with that said, let's move on to the first laboratory experiment. First, we have the sieve analysis. A sieve analysis or degradation test is a practice or procedure used in civil engineering and chemical engineering to assess the particle size distribution, and this test is conducted by placing a series of sieves with progressively smaller mesh sizes on top of each other and passing the soil sample through stacked sieve tower. So therefore, the soil particles are distributed as they are turned by the different sieves. Next is the hydrometer analysis. Hydrometer analysis is based on Stokes' law, which measures grain size distribution by mixing the soil with water and monitoring rate at which the soil particles settle out of suspension. Third is the liquid limit test. Liquid limit test is measured by spreading a portion of the soil sample in the brass cap of a liquid limit machine and dividing it using a grooving tool. Next, we have the plastic limit. Plastic limit, or also known as the PL, is the water content at the change from plastic to a semi-solid state, and this test involves repeatedly rolling a soil sample into a thread until it reaches a point where it crumbles. Next is the specific gravity of soil. The specific gravity of soil, or GS, of soil refers to the ratio of the solid particles unit weight to the unit weight of the water. It is also used to derive several important soil parameters such as the porosity, the dry and the saturated density, and the degree of saturation. Next, we have the traction test. A traction testing is used to measure soil's properties and be used on more solid materials like rock. Typically, a traction testing is used to solve stability problems by determining the shear strength and the stiffness of the soil when retaining reservoirs of water. Next is the standard penetrating testing. The standard penetrating test, commonly known as SPT, was developed to provide geotechnical engineering properties for foundation design purposes. The test is carried out within a borehole, and the result can be used to determine the relative density, bearing capacity, and the settlement of granular soil. Next is the point load index testing. A point load testing is used to determine rock strength indexes in geotechnical practices. The point load test is an index test by which the rock is classified according to the strength. The test can be used to estimate other characteristics of intact rocks which is correlates such as initial, compressive, and tensile strength. And the last one is we have the rebound hammer. A rebound hammer test is a non-destructive testing method of concrete which provide a convenient and rapid indication of the compressive strength of the concrete. The rebound hammer is also known as the skimmed hammer that consists of the spring-controlled mass that slides on the plunger within a tubular housing. And that's all, guys. Thank you for watching. Hope you guys learn about index testing of soil and rocks, which is the lecture 39. Thank you.
Every experience that you encounter has its own unique purpose. Cherish them all. By the way, I am named Johnny Masang, 20 years old, enrolled this subject of Geology, Bsce 1B of EVSU or MOC City Campus. This titled Identification of Mineral and Rock Samples. My objectives is, first, know the difference between minerals and rocks. Second objectives, identify the characteristics of minerals and rocks. Say minerals are strictly defined as naturally occurring chemicals, elements, or compounds formed as a product of inorganic processes. Rocks are composed at an assemblage of one or more distinct minerals. This definition of minerals excludes shales, coral, and other organically formed matter which nonetheless are important constituents of some limestone. When we say rocks, it consists of an assemblage of minerals. They are classified according to this assemblage, the minerals' proportions, and the conditions under which the rock was formed. Rocks are formed in three basic ways, resulting in the following classes. They have only three. First, igneous rocks. Second, sedimentary rocks. And the last is the metamorphic rocks. Those are the types of rocks. When we say igneous rocks, it's formed by hardening or crystallization of high-temperature molten rocks, or what we call magma. When we say the sedimentary rocks are formed by solidification of material deposited to the wind, water, glaciers, or direct chemical precipitation. Last types of rocks is the metamorphic rocks that form by modification of previously existing rocks by the application of heat and or pressure within the earth. Those are the three types of rocks according to their form by their differences and types. The identification of minerals and rock samples. Therefore, I conclude that in identification of minerals and rock sample are related to this subject, which is geology, because geology is a science that deals with the history of the earth or the rocks and its life, especially as recorded in rocks. Therefore, that this subject is related to the minerals and rocks. Based on my observation in this topic, I was very excited and happy because I know that minerals and rocks are different, not only their structure and also the presence of the particles, and they are related to each other, the minerals and the rocks.
And that ends our video presentation about geology for civil engineers.
Thanks for watching, and we hope that you learned something from this video.